Hi everybody, let's do a solution to the displacement problem for our Monte Carlo unit. And the key thing I want you to focus on here is not so much the code, but the thinking strategy, because that's the important thing to take away. It's how you take this multi-layered, complicated problem and separate it into simple parts in your mind. So here's the idea. This is what we want eventually. We want this data table where for different numbers of steps, we have the average ending distance. And so that's kind of the first step, is I just want to be able to display a table. And you might start worrying about, like, where do these numbers come from? How do I get this number? And you can think, well, to get this number, it's an average. What am I averaging? I'm averaging the results of a whole bunch of experiments. So for every single row in the table, I want to run a whole bunch of experiments, figure out what the average result is. But what's the experiment I'm running? Well, for this particular row, the experiment is taking 3 random steps and then checking what my displacement is. And so I'm finding the average of all of those displacements. For the next row down, 4 steps, my experiment would be take 4 random steps and see what my displacement is. So as you can see, there's several layers here. There's displaying the table, but to get the table, you need an average of a bunch of things. And then to get the average of a bunch of things, you actually have to run the things. You have to actually run the simulations or the experiments. So let's see how this plays out in code. So here I'm just going to start writing from scratch. I'm going to make a method called display table. Because I'm programming by intention here, I haven't written this method yet. It makes sense to me that I might want to give it the largest row in the table. So I'm going to display a table up to 50. So let's go ahead and make that method. I'm not going to name it I, because that's not a very informative name. So let's name it something like max steps, like the largest number of steps I'll have. Okay, so displaying the table is supposed to display this data table, but I'm not going to worry about where these numbers come from. So I'm only going to focus on displaying a 2-dimensional table without worrying about the calculations. So how do I do that? I'll make a for loop where I is going to go from 0 to max steps. Probably not 0, actually, because I want to start with 1 step. And I could just print out. So let's pretend I had a variable called the answer. Answer equals 5. I could print out a data table that has my number of steps, and then a space, and then the answer. And if we run this, you'll see that it looks like a data table. Hold on. Oh, I'm running the wrong thing. Okay, so here I've got number of steps starting from 1 going up, but the problem is I'm not actually calculating the expected displacement, the average displacement. So my real question is, instead of assigning answer to 5, how can I really get the answer? So this is where you go into the next layer. Let's pretend we have a method that gives us the thing we want. So my method I'm going to call calculate average. Okay, calculate average distance. Okay, what does it need? What inputs does it need to do its job? I'm not sure. Let's not think about that for a moment. So let's just pretend that this method gives us the answer that we want every single time. All right, how's it going to work? Let's go ahead and create it. So if we go back to the slides, you see that the average is going to run 10,000 experiments. It's going to look at the result of every experiment, find the average, and give it back. So let's make it do that. So I'm going to run 10,000 experiments with a for loop, 0 to 10,000. Let's have a result. So I don't know how to run the experiment yet, but again, let's postpone that decision. I don't want to worry about taking random steps or how many or anything like that. Let's just pretend that we already have a method that does the experiment for us and tells us what we want to know in the end. Because what we really want to know is, what was my ending distance? And that's what I'm trying to average. So I'm going to loop 10,000 times. I'm going to run my experiment. Let's see, to average things, I need to add them all together and divide by how many. So I'm going to call this result sum. And after my experiments, I'm going to say result sum equals result sum plus the new result. So as I'm repeating each experiment, I'm taking the outcome, adding it into this sum variable, and then at the end, I can return result sum divided by the number of experiments I have. So now I'm calculating the average, but notice I didn't have to worry about how does the experiment work. I can postpone thinking about that until I actually make the method that does that. So I think the essence of this strategy is to put off the hard thinking. Like, I know I need a data table. I don't know how to calculate the numbers in the data table, but let's put that decision off. Let's just write a method that calculates a data table, and I'll pretend that I know how to calculate it. Now that I've got the data table, now we can think about how do I calculate the numbers. Okay, so the number is going to be an average. I don't know. I know it's an average of a bunch of experiments. I don't want to think about how to run an experiment, so let's not. Let's just pretend that that actually works, and let's find the average of all the results. Okay, now that I've written the code that I think is going to find the average, now we can worry about how does the experiment work. So how does the experiment work? Well, I'll start my particle at xy equals 0. I'm going to loop for a certain number of steps, let's say 30 steps. I'm going to choose a random direction. So my direction is going to be math.random times 3. So that could be 0, 1, or, it's not enough directions. So now that's 0, 1, 2, or 3, and let's test it. So if the direction is 0, let's go right. If the direction is 1, let's go left. If the direction is 2, let's go up. If the direction is 3, let's go down. All right, so I is maybe not a very good name here. Let's try and rename this. Is that how I rename it? Nope. This I value is really how many steps I'm taking. So I'm going to rename it from I to something that's going to make more sense to me. I'm going to rename it step num, because my step num starts at 0 and goes up to 30. All right, so at the end of taking all my steps, what do I really want to know? I want to know how far did I get. So I'm going to return square root of x squared plus y squared. All right, so far so good. So now let's back on out of it. Something that we didn't look at yet was what inputs do the methods need? And so if you see this here, I've got my data table, but it's displaying the same number over and over and over again. And the reason why is because the experiment I'm running, I'm always taking exactly 30 steps. So let's generalize this method. This method is going to be the same always, except that for different rows, I want to run the experiment taking different numbers of steps. So let's take an input, which is, I'll call it walk length, which is like how many total steps I'm going to be taking. And now I can make this be walk length. So now if the input's 30, I'll be taking 30 steps. If the input is 10, I'll be taking 10 steps. All right, so now let's go back to where I'm running the experiment from. All right, so here, how do I know how many steps I want to take? Well, here I'm trying to calculate the average distance for something. So let's think about where I'm running this from. Oh yeah, so here I am back in the table, right? I'm trying to calculate that y value for my data table for a particular row. So it seems like when I say, could you please find me the average distance, I got to say, how many steps do we want to take? So right now it looks like I is the number of steps. So maybe we should rename this also. So let's rename this, So let's rename this step. And that actually makes more sense for the print statement also, because the first number should be the step, and the second number should be the average expected distance from that number of steps. So when I'm calculating my average distance, I'm going to tell it how many steps should I be taking, which means this needs an input, which is the number of steps I'm taking. And so now that I know how many steps I'm supposed to be taking, when I run the experiment, I can say, hey, experimenters, let's use this number of steps for the walk. And that's it. And so now when I run it, we see an output that's more as we expect. Okay, let's change the problem up. What if the new problem is I want to calculate the average sum I can expect when I roll n six-sided dice? And I want to display the results in a table from 1 to 30. So for example, we've got number of dice, and then this is the average sum that I'll get. So what about our solution can stay the same, and what needs to change? very little needs to change because a lot of the structure is the same. We're still displaying a table. We still need a method that's going to calculate these numbers, and the method that calculates the numbers is going to do it by running 10,000 experiments. So the only thing that's really changing is what's the experiment we're running. So here's my Monte Carlo solution. Let's just modify it a little bit. So I'm going to have my table go up to 30 instead of 50. Step is no longer a good name, so let's call this num dice. And then instead of max steps, I'm going to call it max dice. And then I'm not going to calculate the average distance. Let's just rename it. Let's just call it calculate average. So it's the same method. I'm still calculating an average. I just renamed it. This is the number of dice now. So notice that only the names changed. None of the logic has changed. I'm still looping 10,000 times. I'm going to run 10,000 experiments and then average the results together. So what's the experiment I'm going to run, and what's the result I'm trying to average? I'm trying to find the average sum when I roll that many dice. So running the experiment is I got to roll that many dice and check what the sum is. So let's call this num dice. And now I can rewrite the inside here. So I can say for I, so I'm going to loop up to num dice. Let's have a double called sum. And then let's generate a random number. So result equals int 1 plus math.random times 6. So that's now a number, this is an integer between 1 and 6. So sum plus equals result. And then at the end, I'll just return the sum. So the only thing I changed was the experiment I'm running, but I'm still running an experiment 10,000 times to average the results. And then when I get the averaged result, I'm displaying that in a row in the data table. So the overall structure here hasn't changed very much, and that's the structure that I want you to have in your mind. When you get a new Monte Carlo problem, odds are that you're going to be running a bunch of experiments. And so you should have a method that constitutes just what's the one experiment you want to run, and it should return the information you're interested in. And then you should have another method that does whatever you need with all of the results. And then you can take that method and then you can use it to output the different averages or the different probabilities in a table. So hopefully kind of going back and forth, zooming out and zooming back in and kind of seeing how these things are all separate from each other has helped you start to wrap your mind around the different layers of this problem. And hopefully you'll get a chance to practice taking a complicated problem, breaking it into separate pieces like this yourself. Good luck.